Welcome to Casting Academy. We are in the theory of machines, particularly kinematics of machine, first unit of basic mechanisms. Lot of topics we have discussed. So today our topic is mechanism with the lower pass. Mechanism with the lower pass. What is lower pair? When two elements are connected in such a way, they have fully surface contact or sliding or lower pair, which means two elements are in surface contact or sliding contact. That is called lower pair. Lower pair means fully surface contact, which means sliding. So this is the mechanism of lower pair. Mechanism with the lower pair. Now we go for pantograph. Pantograph. See, you see the interesting applications of pantograph and then go to the description. Applications of pantograph. First of all, reproduction of plane areas and figures such as map, plans, etc. So, reproduction of plane areas, figures, maps, plans, and etc. on an enlarged or reduced scales, which means A4 size or A3 size paper, whatever maybe we want. So, reproduction of plane areas and figures, map, and plans on enlarged or reduced scales, also used to guide the cutting tools, in machines, particularly milling machine, etc. And also nowadays this is used for in the form of modified form of pantograph is used to collect power for electric locomotive. So pantograph is used to collect power, which is used in the electric locomotive. So these are all the interesting applications about the pantograph. Now we go for theory. Theory begin this. Before theory, you see the diagram first. See, O is a fixed point and OB is a fixed link and BE is another link. See the links. OB is a straight link and BE is a another straight link. In this we are connected in such a way that is called jointed parallelogram ABCD, which means ABCD or jointed parallelogram. ABCD means jointed parallelogram. So, what is the idea behind what we have proved? The point E traces always a straight line path which is always parallel to the D, which means the D point and E points always a straight line, or otherwise E traces the a straight line path along with the D. So this is our proof. This is only we want to prove. So we go for that. First of all, you understand the theory first. Pantograph is an instrument used to reproduce to or enlarged or a reduced scale. Here, this instrument is on the jointed parallelogram. Jointed parallelogram. Jointed parallelogram ABCD. ABCD is here with the four turning pairs. 1, 2, 3, 4. Four turning pairs. Jointed parallelogram of ABCD, which have four turning pairs. So bars BA and BC, bars BA and BC extended to O and E. So BA extended to O and BC extended to E. Here these are all the constant length. So we got OA divided by OB equal to AD by B. OA divided by OB, that is equal to AD divided by BE, because of these are all parallel and also straight line, so this ratio will not change. OA by OB always, that is equal to AD by BE. So thus for all relative positions of the bars, thus for all any position of movement in the bars, triangle OAD and OBD, are similar. Triangle OAD OBE, which means smaller triangle and bigger triangle, always similar. Thus, for all relative positions of the bars, triangle OAD and OB are similar. And the points O, D and E, points ODE, always a straight line. You see the straight line. So, points OD always in a straight line. To prove, the point E always traces out same path as described by point D. What we prove? The point E always traces out the path described by the point D. E always follows the point of D path. This is only we prove. The point E traces out same path as described by point D. Here the similar triangles is OAD and OBD. Here the OD by OE equal to AD by E. You just to go through this. OD by OE. So similar triangle AD by BE. So this is the case. Let point O be a fixed point. Let O be a fixed point. Yeah, this is a fixed point. Points D and E traces D dash and E dash. So O be a fixed point. Then points D and E, D dash, E dash moves to D dash and E dash. Similarly, OD by OE, that is equal to O dash D dash by OE dash, because of this will be goes to D dash and E dash. So OD by OE equal to OD dash divided by OE dash. Straight line, you know the straight line D dash, D dash parallel to E dash, D dash parallel to E dash, which is always parallel. Therefore, DE traces out a straight line path. So what we have proved, DE always a straight line. So the D moves along D dash and E moves E dash. So already in a straight line, or so we also same path in parallel way. So always D follow D dash and E follow E dash, which is parallel to D dash equal to E dash. So our proof is DE traces out straight line path. So just you see the okay. Now our next topic is straight line mechanisms. Now our next topic is straight line mechanisms. What is mean by straight line mechanisms? Mechanisms permits only relative motion of an oscillatory nature along a straight line. So oscillatory nature along a straight line. First one is exact straight line mechanism. Exact straight line motion mechanism, which have all are tanning pairs. Just you see the arrangement first. OA, OA, OA is the chord and OB is the diameter of the circle, and OPQ is a straight line. Then OAB is a straight line. This is the main arrangement, OAB and OPQ. Here remember the OP always perpendicular to chord, and also Q always perpendicular to O produced. The point Q always produced to OP produced, and also OAP always perpendicular to OB. This is the idea. So now you see the point O on the diameter of the circumference of the diameter of the circle OP. This point is on the circumference of the circle, which is diameter is OP. Let OA chord, OA is any chord. You take it as let OA equal to any chord, and point B on the OA produced. The point P is on OA produced, which means OA extended to some point. That point is B. This is the arrangement. Here you know OA into OB equal to constant. As we know, OA into OB equal to constant. Then locus of point B, a straight line perpendicular to OP. Then OA, first of all, OA into OB equal to constant. Then locus of B, move a straight line perpendicular to OP. Proof: draw BQ, BQ perpendicular to OP produced. Draw BQ perpendicular to OB produced. Draw BQ perpendicular to OB produced. Draw BQ. Here you see first of all OA into OB equal to constant. Then locus of point B, always locus of point B in a straight line perpendicular to OP produced. Just we proof locus of point B is a straight line perpendicular to OP. Draw BQ perpendicular to OP produced. Just join AP, join AP. Similar triangles we obtain. We obtain similar triangles, which means OAP and OBQ. OAP and OBQ both are similar triangles. So now you got therefore OA by OP equal to OQ by OB. The ratio is OA by OP equal to OQ by OB, or OP into OQ equal to OA into OB. So finally we got OQ equal to OA into OB and divided by OB. Okay. But you know, always OP is constant. At its diameter of the circle, the OP is constant. Therefore, if OA into OB constant, if OA into OB equal to constant, then OQ will be the constant. That's all. Hence, point P move along a straight path BQ perpendicular to OP. The point BQ perpendicular to OP always. That is the idea. So straight line mechanism. So next our interesting topic is Peaucellier mechanism. Just to see the arrangement first. Peaucellier mechanism. This is also a jointed parallelogram. So O1 is a fixed link, and another links are OC, O1A and AD, BD and BC. These are all the another links. Okay, here the PQ always produced to OP. Just previous case, BQ always perpendicular to, here is perpendicular to OP produced. This is only we want proof. First of all, you understand the fixed link O1 and straight links O1A, OC, OD and AD, DB and BC, and finally CA, straight link. The point A moves along circle with the OP. You know, the point A moves along with the circle OP by link O1A. By means of fixed link O1A, we move the point A along the circumference of the circle. So the point A moves along the circle. Here AC equal to CB, that is equal to BD equal to DA. You see AC equal to, what is AC? AC equal to CB and DB and AD. So these are all the jointed parallelogram. All the lengths are equal. Just to OC into OC equal to D, COD. OC equal to OD. This is also parallel and same length. And O1A, O1A. Sorry, O1 and O1A. These are all also same length. This is the main parameter. Proof. What we prove? Just OA into OB remains constant when O1A rotates. Just you see the OA into OB. OA into OB equal to constant when O1A rotates. As the mechanism moves, OA into OB is a remains constant. Just we want proof. Here join CD, which bisect at the point R, AB. Join CD bisects AB at point R, and right angle triangles ORC and BRC we obtain. Right angle triangle ORC and BRC, BRC. So top of ORC and BRC are the right angle triangles. So here the Pythagoras theorem, OC square equal to OR square plus RC square. First triangle OC square equal to OR square plus RC square. Then next to BC square equal to RB square plus RC square. So BC square equal to RB square plus RC square. RB square plus RC square. So subtracting the equation 2 from 1, we got OC square minus BC square, that is equal to OR square minus RB square. Subtracting equation 2 from 1. So that is equal to OR plus RB into OR minus RB, that is equal to OB into R. You see what is OR into RB? OR plus RB. OR plus RB. OR plus RB into OR minus RB. OR minus RB, that is equal to OB into OA. Since OC and BC are of constant length, so you know OC and BC. OC and BC are constant length. Then OB, therefore OB into OA always constant. Hence the point B traces a straight path perpendicular to OB. Hence the point B traces a straight path perpendicular to diameter of the circle OB. I hope all you will understand about the mechanism with the lower pairs of pantograph and straight line and Peaucellier mechanism. In remaining classes in future, we will see the related formula for this one. And thank you for all.